So this is a video for the first unit test in pre-calculus. It's for Unit 1, Topic 1. So for these first 8 questions, we're going to state the parent function and then the transformation. So number 1, the parent function is quadratic. And the transformation, this minus 1 has the graph go down 1. The parent function number 2 is absolute value. And the transformations are the minus 1 with the x means right 1. And the 1/2 in the front is a vertical shrink or dilation of a half. The parent function number 3 is the square root. The minus 2 at the end is down 2. And the negative coefficient is a reflect over the x-axis because it's multiplied on the whole function. I just realized that my stand here is in my video. Okay, so for number 4, the parent function is quadratic again. And the different transformations, the plus 3 at the end is up 3. The plus 1 with the x is left 1. The negative coefficient is reflect over the x-axis. And the 2 coefficient is a vertical stretch of 2. The parent function number 5 is linear. And this is down 2, reflect over the x-axis, and vertical stretch of 3. In 6, we have the absolute value again. Down 2, left 5, reflect over the x-axis. A different one. So to the 3rd power is a cubic function. And this one's up 4 and right 2. And last but not least, a quadratic. That is up 1 and reflect over the x-axis. Verify that f and g are inverses by showing the compositions both equal x. So f of g of x is f of 1/2 x minus 5. So I'm going to take this 1/2 x minus 5 and replace it in the x of the f function. So that's 2 times 1/2 x minus 5 plus 10. And then you should show your simplification. I'm going to distribute the 2. And then negative 10 plus 10 is 0. So that leaves me with x. Now going the reverse, g of f is g of 2x plus 10. I'm going to take the 2x plus 10 and replace it in the x in the g function. Distribute the half. And that equals x as well. So repeating that process for 10, f of g so I took the 3x plus 9 and I replaced the x with what I'm substituting in. Distribute the 1/3. And now g of f So the 1/3 x minus 3 gets replaced in this x. Distribute the 3 and simplify. Find the inverse. Okay, so we have to build the function. I like to start with the original. First, x got multiplied by 4, and then we subtract 5. So going backwards to undo this, we would add 5 and multiply by 1/4. So the inverse is x plus 5 all times 1/4. That looks horrible the way I wrote it. It looks backwards. I'm gonna make that 1/4 x plus 5. If this backwards doesn't work for you, I'll show you a different strategy for 12. First, let me build the original. So then going backwards, if I want to start my inverse, to undo the square root, I would square it. Then here I'm going to subtract 3. And then I'm going to multiply by 1/2 or divide by 2. So let's say divide by 2. And this is then the inverse for number 12. And then lastly, first x got squared, then times 3, then added 7. So going backwards, to undo this, I would subtract 7. Then to go backwards here, I'll divide by 3. And then the last step is going to be to square root the entire quantity. So the inverse, is square root of x minus 7 over 3. So 14, x squared plus 8 is not 1-to-1. Explain why, using a definition. Well, so first, 1-to-1 means that the function and the inverse are, the original, and the inverse are both functions. So if I graph x squared plus 8 like this, the original is a function, but the inverse would look like this, and that is not a function. So the inverse is not a function. I'm going to abbreviate, therefore f of x is not 1-to-1. To restrict the domain on the original, which is this one, I can say if x is greater than or equal to 0, or if I take the left side, x is less than or equal to 0, that would eliminate half of the inverse, and now that relation becomes a function. Okay, for 15, for the given, state the restriction, find the composition, and then state the restriction. So g of f is 4 over x squared plus 1. So this is g of f of x. Let's simplify this fraction here. When you square a fraction, you square the numerator and square the denominator. If I want to combine this to one fraction, I need a common denominator. Let me get another color. So to make a common denominator with x squared, I have to multiply the numerator and denominator of the constant by x squared, and we get 16 plus x squared all over x squared. So then the restrictions, when you have a fraction with the denominator, we can't substitute any value in that would make the denominator 0. So x cannot be 0. Are there restrictions on the domain? Because that would make the denominator 0. G of f of 4. So g of f of 4. So first I need f of 4. So 2 times 4 is 8. So that's g of 8. So we have to do 8 squared, 64 plus 1. Now I'm not going to use my calculator, so 64 times 3, you could do the basic arithmetic like we were taught a long time ago. If you don't like this, you can do 60 times 3 and 4 times 3 and then add those together. If you're a box method fan, you can even do box method with 60 and 4 to make 64 and 3. You multiply and add these together. So all three results give us the 192. So plus 1, our final answer is 193. Graph the piecewise function. Okay, so I like to make a table of values for each piece. For x minus 3, I'm going to start at 2 and go smaller because it's every x less than 2. So 2, 1, 0. 2 minus 3 is negative 1. 1 minus 3, 0 minus 3. So when I plot those two, it's not equal, so I do an open circle. Oops, that's in the wrong spot. Don't use pen like I did on the test. There we go. 2, negative 1, 1, negative 2, 0, negative 3. And then x squared for greater than 2, so 2, 3, 4. Squaring those numbers. And also an open circle because it's not equal. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's a little bit off. And then it's a quadratic, so we're going to make sure to do a nice curvy shape. It's not a straight line. And there is our graph. So is the function continuous? No. If not, state the type. It's a jump because of this. As x approaches 2 from the left, so here's when x is 2. From the left, the y value is negative 1. As we approach 2 from the right, the y value up here is 4. There's a mistake here. This minimum should be at negative 0.63. Okay, so to graph this, first I need to think about end behavior, x-intercepts, and then we give you the maxes and mins since there's no calculator to use. Let's do end behavior first. It's an odd function with a positive leading coefficient. So that means the right end behavior goes up to infinity and the left end behavior goes down to negative infinity. Then the x-intercepts. I can factor this cubic. So let me rewrite the function, and now there's a greatest common factor of x to take out. And then what multiplies to negative 2 that adds to 1 is going to be positive 2 and negative 1. So if I set each of these factors equal to 0, I get my x-intercepts. So let me write them here, 0, negative 2, and 1. So I can plot those. And now with this end behavior and the max and min, so let me put the max and min in negative 1-ish, 2-ish, a half, negative a half. Oh, that's squishy. I can see the graph's going to increase to there, decrease, and then increase like that. So the y-intercept I can, nope, I'm gonna go in order. Sorry, slow down, Miss Weiss. So the domain, if I look at the function, or I even look at, if I look at the graph or the function, there's no restrictions when you have a cubic. I can see the same thing here. It goes in all x directions, so the domain is all reals, or we can write it this way. The range is the same. It goes down forever and up forever. And increasing and decreasing only uses the x values of the maximum and minimum. Only the x values. So our graph is increasing from negative infinity to negative 1.22. Then it's decreasing from negative 1.22 to 0.55. And then it's increasing again from 0.55 to infinity for this last piece. The y-intercept is when I substitute 0 in for every x. So it's f of 0, and in this case that is also 0. And then for end behavior, as x goes to infinity, the function goes to infinity, up. And as x goes to negative infinity, the function goes to negative infinity. Algebraically determine if the function is even, odd, or neither. So we have to substitute in negative x for every x and simplify and then compare. So negative x squared simplifies to x squared because a negative times itself is positive. So now if I look at the simplified equation and the original, they are the same. So that is even. Okay, 420. C is the cups of food, H is height in feet, and weight is pounds. The weight of a dog is the function of height, if the height, and is modeled by the equation. Weight of height is 2 times h plus 1. The table shows the cups of food the dog eats per day and the weight of the dog. What does C of W of 2 mean in the context of this problem? Well, if cups of food is based on the weight and weight is based on the height here, that means the number of cups of food when the height of the dog, because that's what's in the weight, when height of dog is 2 feet. Make sure to include your units. Find the value of C of W of 2. Well, so first let's find weight of 2 using this function. That's 2 times 2 plus 1 for 5. So then if I go to the weight in the table of 5, that's right here, the cups for 5 pounds is 0.5 cups of food. Okay, so that is all the homework. The next page in the packet is a nice summative review warm-up, so I'm going to do that as well. Mrs. Weiss gets on an escalator and rises to the top floor in 10 seconds. She starts at a height of 0 feet, and the top floor is at 50 feet. Okay, wait a minute. I gotta draw that. She starts at 0 feet. The top floor is at 50 feet, and it takes her 10 seconds. Okay. She claims that during the 10-second ride, she will have been 34 feet off the ground. Is she correct? Yes, because 34, well, yes. Riding an escalator is a continuous a model, wait a minute, how am I gonna say this? I wanna say that riding the escalator is continuous. I'm not jumping over any feet. I'm gonna sneeze, excuse me. So the model of riding an escalator is continuous. Therefore, if the max is 50, she had to pass through 34 feet. Without using the identity function, which is just y equals x, write a possible rule for f and g. So g is the inside function and f is the outside function. G is inside, f is outside. So my rule, well look, x plus 8 is inside these parentheses. So I'm gonna say that x plus 8 is the inside function. And then anywhere there's an x plus 8, I'm gonna replace with just an x for my outside function. Because when you then go to do the composite, the x plus 8 gets replaced, oops, I forgot an x here. And a squared here. The x plus 8 gets replaced in each spot. For f of x, complete the following. I think we're missing a graph. Okay, we're not missing a graph, we're missing a function. So I'm gonna write that function in here. It's a piecewise. Oops. Okay. So I don't want to have to do a whole graph just to base on these 3 values. So what I'm going to do is for each piece, I'm going to find out the value at 3. So if you think of like an XY chart, so at 3, this function is going to have a y value of -7. And then x squared minus 7 at 3 is going to have 9 minus 7 is -2. So these are not the same y value at 3, so it's a jump. And then from the left, if you think of a coordinate grid, from the left is this way, which is the piece coming from less than 3. So the y value is -7. And then the little plus sign is from the right, this direction, which is coming from more than 3, so that's a y value of -2. Describe the transformations from the parent graph. All right. The negative coefficient is reflect over the x-axis. This is left 1. Now here, down 6, and I'm forgetting the 3s, that's a vertical stretch of 3. 5, this should be x squared plus 7. Okay, explain is not 1-to-1. Explain why using the definition. 1-to-1 means h of x and h inverse of x are both functions. H inverse of x is not a function, therefore h of x is not 1-to-1. Oops, sorry, you almost couldn't see that. So if I think of a picture, x squared plus 7 is up here, translated up 7. So again, the inverse would be over here, not a function. So what restriction could we put? I'm going to say x could be greater than or equal to 0, because then that eliminates this part, which would eliminate this part, and therefore the graph is then a function. So for your test, you have to make sure you can do all of this test review material completely on your own and confidently in order to be ready for the unit test. Happy studying.